Hello guys, welcome back. In this lecture, I should be explaining the logical operators. But the thing is, you will understand if I explain along with the concept of if statements in the next section. So guys, I'm going to skip the logical operators for now and will be explaining bitwise operators. Okay. So now today in this lecture, we will be seeing bitwise operators. So for bitwise operators you should be remembering AND gate and OR gates. Okay, so firstly let me create a new file, control N. So what I'll be doing now is, I'm going to write a AND gate. See, AND gate, I hope you remembered this, right? In first input A, second input B, output. Okay, so for 0 0 the output will be, for AND it should be multiplication 0, and for 0 1 output would be 0, and 1 0 the output would be 0, and for 1 1 the output would be 1. Cool. And now I'm going to write OR gate. So there will be two inputs and a single output. So 0 0 0 1 1 0 and 1 1 are the combinations. Okay, so for 0 0 the output will be 0. We should basically add this. For 0 1 the output will be 1. For 1 0, for 1 0 the output would be 1. For 1 1 the output will be 1 again. So now, so along with and OR, we also need to know about XOR gate. There is a gate called XOR gate, and we have two inputs for this XOR gate and an output. Two input XOR gate. So again the combinations are 0 0 0 1 1 0 and 1 1 are the combinations. Okay, the output will be, for 0 0 the output would be 0, for 0 1 the output would be 1, for 1 0 the output would be 1, for 1 1 the output would be 0. Yeah, these are the basic gates you need to know. Okay, and do you guys know how to convert binary numbers to decimal numbers, or decimal numbers to binary numbers? I hope. See, if you guys don't know, copy this. Binary to decimal, binary number and the subsequent decimal number I'm going to write. Okay, so I'm going to write the binary numbers for all possible 3 input combinations. This means 0 0 0 0 0 1 0 1 0 0 1 1. Okay, the same way 1 0 0 1 0 1 1 1 0 triple 1. So these are the binary numbers. Okay, so these are all the possible combinations, and the equivalent decimal numbers are 0 1 2 3 4 5 6 and the final number 7. So I will be writing the codes in these combinations only. Since this is not the correct time to discuss what are gates, the binary numbers, the decimal numbers, I'm not gonna discuss more about this. Okay, so if it is a digital electronic class, I would love to teach all of these in details, but this is a C programming, so no need to discuss about this all. If you are not aware with these gates and binary number to decimal numbers and decimal to binary conversions, you better try to write these. Okay, note these all things. Okay, pause the video and note. However, let us start with our coding now. So hash include standard input output dot h. So int main, what I'm going to do is as you all know, we are going to discuss bitwise operators. Bitwise operators. In these bitwise operators, we are going to see about AND, OR, XOR, left shift, also right shift. Okay, these all comes under bitwise operators. So what to do now? See, let me take two inputs, int A and int B. Okay, and let me print a value of integer %d, comma. So first let me A ampersand B. What does ampersand means? So ampersand means the symbol of AND. The symbol of AND is ampersand, and the symbol of OR is this thing. See, and the symbol of XOR is cap symbol, and the left shift, the symbol of left shift is less than, and the symbol of right shift is greater than. Okay, these are basically the left shift, right shift, XOR, and OR symbols. So I am doing the AND operation here, and I have to declare one is 0 and the other is 1. What if 0 and 1? Go to AND truth table and see the combination 0 1. And where is AND? Yeah, the combination of 0 1, the output would be 0. So see the output. Let me save it under bitwise operators. Okay, the concept of bitwise operators. Right? Yeah, save. What is the output? You see here, right? 0. So the AND of 0 and 1 is 0. What is the AND of 1 and 1? Go back and see the table, AND table 1 and 1, the output would be 1. So let me compile this and see the output 1. The same way, check it for OR. See, OR, take it both zeros and check the output. What is the OR of 0 and 0? 0. And let me check it for 0 and 1. What is the output of 0 and 1 for OR gate? 1. In the same way, you can also check for XOR gate with this symbol. Okay, these are basically the AND, OR, and XOR gates. Okay, so what I'm gonna do is now take the input A as 6 and B as 5. Okay, so the binary conversion for 6 is 110, and the binary conversion for 5 is 101. You can verify it from here. The value of 6 is 110. The value of 5 is 101. So these are called basically the bits. The zeros and ones are the bits, 2 bits. So this is basically the bitwise operation. So everything is gonna be in bits. Don't expect in decimal numbers. All the numbers should be in binary. So I'm going to do A and B. Okay, so now see what happens now is, let me explain you what is the 1 and 1 and with 1. The input of 1 and 1 in AND gate is, go to AND gate, the input of 1 is 1. is 1. The input of 1 and 0 is 0. You can go and check, and 0 and 1 is 0. So what is the decimal conversion of binary number 100? Here is 100 and the decimal number is 4. So the output should be, guess, 4. You can see the output 4 here. In the same way, you can do the same thing for OR. If we do OR, what is the output of OR gate if the inputs are 1 and 1? The combination 1 and 1 in OR gate, you can see 1. 1 and 1 is 1. 1 and 0 is also 1. 0 and 1 is also 1. You can go back and check there. And what is the decimal number of the 111 combination? See, the 111 binary code is, in decimal it will be 7. So let me check this. What happens now? Yeah, 7. So you can test it for different numbers. You can do the operations on your own and you can check. And we are done with AND gate, OR gate, XOR gate operations. Okay, you can also check for XOR gate operations using the same technique which I have used now. And now we are going to be dealing with left shift and right shift. You know, the left shift and right shift are the important parts in this lecture. So what is left shift and what is right shift? First, let me explain you about left shift. So I want to delete both of these lines. Okay, so delete both. Okay, I am taken A as 6, declared A as 6, and I want to left shift the A by 1. Okay, so how will we write A left shift 1? So what is mean by left shift? In the name itself, it is saying that it should be shifted to left. So the input is 110. The 6 means 110, right, in bits. So we have to shift it left. So every number will be shifted to left and the last number will be added 0. Simply remember this. If it is a left shift, add a 0 to right. Okay. If this is a left shift, add a 0 to right. So we have added a 0 to right, and the combination of 1100 is, 4 plus 8. 4 plus 8 is 12. So the binary equivalence is 12. So sorry, the decimal equivalence of 1100 is 12. So if we left shift A to 1, what would be the output? The output will be 12. What if we right shift it by 2? If it is right shifted by 2, add 2 zeros to the right. Okay, if we left shift it to 2, add 2 zeros at the right side, and the decimal equivalence for this is 24. Okay guys, so let me compile this and see 24. In the same way you can do the right shifts. Okay, what if I do the right shift 1? So 110 is the input, and if we do the right shift, what happens to right shift? We have to shift it to right. So remove a number. Okay, so remove the rightmost number. So remove 0. Remove the right number. So for left shift, you are going to add a 0 to the right side, and for right shift, you are going to delete a number on the rightmost. Okay, if it is a right shift by 1, the output is this. What is the combination of 1 1? It means 0 1 1, right? So what is 0 1 1? 0 1 1 is 3. So the output is 3. Let me compile this. See, this is 3. Cool. So what if I right shift it by 2? Right shift it by 2 is nothing but it happens to right shift one time and again try to right shift it. Okay, if we try to right shift again, we'll remove another number on the right hand side and it will be 1. Okay, the decimal format for binary number 1 is 1. Okay, 0 0 1 is 1. You can see 0 0 1 is 1. So the output should be 1, right? See the output? Yeah, it's 1. How cool is it, right? So in this lecture we have seen the AND gate, OR gate, XOR gate, and the binary to decimal and decimal to binary conversions. I haven't explained how these binary numbers came, because in our childhood only, I mean in the elementary classes only, they will teach how to change this. Okay. And also if it's a digital electronics, I would love to teach, but it's not the digital electronics, so I'm not gonna teach because it takes so much time, it will consume so much time. Okay. And also the operations, and operation, or operation, XOR operations we have seen, and these are the symbols, you know. And the left shift and right shift also have been done now. It may be a little confusing, but if you practice more, it will be so much clear. So that's it about this lecture. I hope you enjoyed it. Thanks for watching.